Sawadee krap. This is what I'm thinking right now. I'm honored to be here. I love this topic. This is all I do. And I'm nervous. But I know what you're thinking. You're thinking, that guy does not look like a data scientist from Seattle. I'm not wearing boots. I have a white dress shirt on, really? I don't even have a tattoo. The reason that's important is that the math, the science, experimental design, and visualization techniques of data scientists have been around for decades. My entire career has been spent looking for ways and new insightful ways to get information, to get insight out of the data we have around us. The only difference is that we now have stunning amounts of data to work with, incredible compute power, and the role that data science is playing in business is fundamentally different. That's why this is exciting. The other thing you might be thinking about is why there's a picture of some kids playing in a circle in the sand. And this is why I'm upset about data scientists. I see so many examples where data scientists are very happy to work among themselves in a small place on a small, cool problem in a vacuum, and nothing gets done. Not because they're not having fun in that circle, but they're not understanding you have to connect data science to business. And the key of this theme about agility to go fast, about DevOps to get work into production, is going to hinge on the value we get out of data science. So that circle, if you take that circle of the kids and you put it in the middle of the slide, that's data science in the middle. My point is that you cannot add value as a data scientist unless it's connected to a quick way to work and to business outcomes. It's that simple. In fact, that makes a pretty good agenda. I'm going to talk first about the core of data science. I might surprise you because skills I'm going to talk about aren't the skills you might be thinking about. Then I'm going to talk about how we get things done, which is the heart of Agile and DevOps. And then we're going to close on the most important part, which is business outcomes, being data-driven, and customer centricity. And I'll tell some stories in here and give you a sense of the kind of capabilities we have and that we can deliver as data scientists. Sounds like fun, doesn't it? All right. Let's start with the basics. Data science is a role. Machine learning, a part of AI really, is tools. So the idea of data science is very simple. And again, this is why I can have a long career as a data scientist. It's about using scientific methods. That's why the word science is in there. And models and math and algorithms to get value and gain insight out of our data. It's that simple. Machine learning is the collection of algorithms, the models that we can use that allow the computers themselves to act somewhat like they were humans. They can infer, and they don't need as much guidance as we might have traditionally given them. In the middle are the outcomes. These outcomes are very important. And I just say, work in a company that does thousands and thousands of projects worldwide. And if I was to think about the outcomes of where we see data science being applied, it's in 4 areas. The easiest, the fastest, the most obvious is about improving the operations. You have an existing process. I'm going to use math and models to make that process run more efficiently. I call that optimize operations. Second, in terms of popularity, is changing customer experiences. You want to create experiences which are consistent, personalized, and self-learning. The experience as people interact with your company and your systems become smarter. We have to think about what we do to improve the productivity of our workforce, our employees, our doctors, our nurses, our staff. And then finally, the real fun one, and I'll have a couple of examples at the end, we actually change the way we can build product. So let's move on from definitions to probably the worst visual slide I've ever written or drawn. So apologies, but you get the idea of how this works. When I started in my career, I built very large data warehouses on very expensive platforms. I had very specialized teams of statisticians, data scientists, quants, whatever you want to call them. They're very specialized and very expensive. And my business customers would come to me with a piece of paper that says, here's a request, right? I need to understand the variance in sales by region, or those kinds of things. And we'd take that, and our smart people would do their work, and they'd hand back a picture. It might be a chart or something like that. And the data we had, because there's so little of it and was so important, we generally tended to protect it. Our culture, our human culture, was hesitant to think about data being used widely. Contrast that to where we are today. Obviously, it's very, very different. Today, I work, and my teams work, and all of you work in an environment where data is everywhere. When you walk in the shopping mall at lunch, half of the teenagers are on their phone. Google knows where I am right now. They could probably figure out the building I'm in. They could probably figure out the event was here, and they could probably figure out what I'm doing here. That doesn't bother me because that's just almost assumed because of the benefit we get of so much data. So data is everywhere. I think of it as ambient. Analytics are no longer the specialized platform where you have to bring your request to my data and I run my analytics and give you an answer. I'm embedding analytics into wind turbines. On the edge, they're in workflow. My point here, if you're a data scientist, is you can no longer be the introvert in the back room, quietly responding to and using cool tools. We're actually changing the way business runs. There's never been a better time to be in IT and in analytics and be data-driven as right now. That's why I love this topic and why I love being a data scientist. This is the same slide. It's a standard Microsoft slide, and it's a slide about maturity of analytics. And again, the point I'm going to make here is the impact that data science, agility, and DevOps can have. That top row is how many companies work today. So imagine you're in IT or finance, and you get a set of data on Friday afternoon, 3 o'clock. You download it, you drop it into your Excel spreadsheet, and the reason you're doing this is you have a meeting with your general manager on Monday afternoon, the standard weekly status meeting. So you get your data, that's the quickest you can get it, it's Friday afternoon. You spend Saturday organizing, cleaning, sorting the data, looking at it, say, oh my gosh, I need a little bit more of this. Sunday, you're looking at measures and values. Monday, you're panicking because you got to take these charts and put them in the PowerPoint deck. Then you got to make sure the PowerPoint deck is on a thumb drive. Then you got to make sure you're in the room in time. And then the meeting starts. About Monday at 3 o'clock, the general manager is asking questions. Where did this come from? How does this work? It's not till about Tuesday afternoon that you as a business can take action, make a decision. So the two things that have happened in there is manual work and people talking. Our job in data science is to reduce that time. In reducing that time, you get better quality, you make decisions faster, and I can do things like not waiting till Tuesday to find out there was fraud. I can find out 20 minutes later. And in doing that, the math has to change. You can no longer rely on the descriptive statistics up here, backwards looking, historical. That doesn't work. I have to be looking forward. So this is why predictive statistics and prescriptive systems that literally will start to make recommendations. I'm not replacing humans. I'm simply allowing that general manager at Friday at 3:15 to see trends in her business and make change. Again, the first point, previous slide, was our world has changed, that data is ambient, analytics are everywhere, and therefore the jobs we have in IT and as data scientists have never been more important. This is the emphasis why our math has to improve. The reason we do this is to go faster and make better decisions and bring speed to action. Okay. Those cornerstones are important because these are going to gate how our careers work and what we look for in the kinds of people we hire as a data scientist and where you can be most effective. I was asked to talk about the skills that I believe data scientists need, and this is not a full list of the skills you need. You notice things like R, and Python and Jupyter Notebooks aren't on this list. Because most people I meet, I interview a couple hundred data scientists a year. I meet lots of them. I have several very good ones working with me. These are the skills I don't see and I wish I saw more. So this might be the part of the presentation where I'm providing a little bit of advice. And I don't have time to go through all the skills here. I'll do them quickly, but I'm going to spend a little bit of time on collaboration when we talk about Agile and DevOps. I'm going to spend a couple slides on visualization because I think it's super important. Okay. Scientific process. Just because you know R or Python does not mean you know statistics. We look for people who know experimental design. You need to understand what a control set of data is. You need to understand where the data you've been given to work with is statistically valid to answer that question. You need to understand A/B tests. You need to understand how to run an experiment when there's 15 other experiments running at the same time. Scientific thinking and experimental design is fundamental. Stats is useful to back that up. Earlier, in fact, in the opening presentation, they talked about design-led thinking. Think outside in, not from the data out, but literally, what is the story your customers are trying to tell? How are you going to change their experience? The work coming out of Stanford in Microsoft, we relicensed some work based on the IDEO methodology, is a place to start. These skills about learning how to get true requirements in terms of user stories and user personas are fundamental to being a good scientist. Agile has been talked about already. I'm not going to talk about it at length. You'll see a brief period on this. I'll come back to visualization. They're soft skills. If you're not curious, you'll have a hard time really adding value back to your business customers, saying, you asked me a question, but I've seen something here and this doesn't make sense. Curiosity is just innate. It's a genetic trait, and all the good scientists have this, as do everybody in IT, actually. Agility is implied because of the pace of our business, and collaboration is fundamental. This gets back to that circle where I started. If you're working in isolation and you find yourself only talking to other quants, you're probably not thinking about the breadth of collaboration you need to be effective. Okay. This is my passion, and I'm going to spend 2 slides on it, and I'm going to give you a homework assignment. In preparation for this topic, I asked my team, who work worldwide, to bring me the best examples of data visualization they've ever seen. We had a bit of a contest in this last week. It was actually fairly humorous, and I found that my team, even though I'm talking about collaboration and spirit, they're actually pretty mean when they have different opinions. The reason visualization is important is because this is how we communicate very complex patterns we see in huge data sets to individuals and business executives who have limited time, have to make big decisions, they have to make it quickly. This is what came to the top. The links are on the slide. Give yourself an hour because it's a pretty emotional journey. The images, the flowers, the petal on each flower is a day in a 120-day period of a child, a sick child. The information adjacent to that, the red dots, are literally measures of blood chemistry day by day. There's even nudges in here on the days where that daughter's, whoops, it's not good at the user interface. Colors were on that day the mother was away, and it changed the emotional state of her daughter and physiologic change. I can't do this slide justice, but it's brilliant, and the music behind it is brilliant. It's worth, if you want to see a high bar, this is about as high as you can get. Now, there were runner-ups in the contest, and here's, this will be a bit of the homework assignment. An easy step to take, which I would recommend almost anyone, is start with the basics. 20, 30 years ago, Edward Tufte really said, here's how you communicate complex quantitative information in simple ways. And it's a nice base to work from. You may have taken it in university or seen it. All of these are kind of fun. I would argue some of these are a little edgy, and at the time they were appropriate. But again, if you want a place to start, my intent here is I'm trying to create a community worldwide that when I meet a data scientist, or they come in to interview, or you go to talk about your work, not just bringing that architectural picture or the pseudocode of the algorithm. You're actually, like an artist, bringing what you use to communicate. What are those images? Because if you can connect that, if people see that you understand business, you understand the math, you can work with data, and then you can communicate it, you'll have a job for life. Okay, that was my data science part. And let's talk about getting things done. I've managed a lot of data scientists, and this is not an uncommon comment. But if you take this apart and you bring the people into the room and say, what's really going on? They describe a day that looks something like this. Now, I made this font a little bit smaller. I'll make this easy in a moment. Basically, there's some cool work in here, which is the data science, and there's issues before and after that. Generally about getting the data ready, and generally about getting this out in production and supported. Again, if you're working in a circle and a solo, this can be pretty hard to get things done. This means that there's a process. This is the exact same slide, graphically, of getting data ready, training and organizing, and deploying it. Because there's a process, you realize that data science is a team sport. So I made it simple. I've extended the process a bit because honestly, whoops, way over here, of course, there's people like business architects and strategists who come up with the ideas that become the use cases that lead to discovery of both data and process, that lead to the development cycle, that lead to production and optimization. So ideas come in one side, impact, whether it be financial, environmental, humanitarian, whatever the benefit, comes out. And of course, we listen to that because you can't, if the models are learning, observations here should come back to new use cases. And the mapping on the bottom isn't quite right. All I'm trying to do is illustrate the point that there's multiple roles that all have to work together for this to work. The best data scientists are actually involved all the way here over in discovery, because that's where you set expectations with the business about model accuracy, the fact that this work is not not deterministic, it's probabilistic. All those kinds of things you want to do to make sure your business customers understand the nature of the problems you're solving, what the results are going to look like. Okay, so since that's a process and I drew it incorrectly as linear, that means you can end up with a model. I'd like to introduce you to a process called Team Data Science Process. This is the model in Microsoft that we use internally and that we give to our customers. It's public domain. The link is down here. Help yourself to it. The FAQs are out there. The ideas, the styles, all those kinds are there. The change is, and you'll see that picture we had a moment ago with the linear process, you'll see those elements. It starts with business. You'll see a phrase around data acquisition, but you'll notice what's different is it correctly is a circle. And you can step back and forth between phases. This is Agile. What we've done is take what looked like a waterfall linear process and put it into discrete building blocks, discrete capabilities that can work with each other in 1, 2, 3 week-long sprints. This is how you get agility. Think of that process running like a whole bunch of steel balls going down an assembly line. From this, I'll pause there. My point was that data science is an amazing, cool thing, but you can't do it by yourself. Because you're going to work with others and because you want to work in an agile fashion, you've got to believe that lots of companies have built processes like this, and this is a skill you'll need. Now, I'm going to step into a little bit of Microsoft. It might look like a Microsoft commercial. It's not intended to, but I have to address how we as software companies who are here to enable data scientists, how we think about our products. So the way it works is I'm with Microsoft, so I'm going to talk about Azure machine learning and that kind of a thing. But the concepts are the same. The first thing we have to do is realize that data scientists should be really smart and they should be lazy. Right? You're trying to be efficient. I'm trying to go fast in these quick sprints. So the best thing we can do as a software provider is realize that some of the things you want to do, you're going to do all the time. Lots of people do them. If you need to do translation, NLP, you want to do vision input and pattern matching, those are things that we can build. This is pre-built services called cognitive services here that you can just pick up and use. They're on the platform. That allows the data scientist to say, I've got Lego blocks to work with. I'll take this one and this one. Because your IP, what you do, and your company's intellectual property is about how you put these blocks together. You also have to think that there's lots of data. We get that it's in lots of different formats. We understand that it may be simple sort of things like traditional relational. It might be documents, and more it's probably graph, network graphs, graphs of expertise, graphs of customer relationships. All those need to be supported in our core platform on Azure. Below that is really cool. We also realize in our data centers, people will be doing neural nets, deep machine learning. And we can actually build chipsets, literally the gateways, the graphical processing units, chipsets, so that when you run an algorithm, we can match it to the right compute resource to get the optimal speed. This is what you should expect and how we think about stacking up our tools and capabilities so you have something to work with. Then, of course, there's tools. Yes, there are proprietary tools from Microsoft, Azure Machine Learning, and things like that, but we're a very open source company. We do more open source development than we do with our own tools. And the idea is that you as the data science teams, as companies, should be able to pick the right tools that are appropriate to your job and apply them. And that'll be decoupled from all the services that are available and the back-end compute and data storage. That's our approach. If I drill down, it'll allow me to go one click down, because I just wanted to be more specific on opening up some of this, and then I want to lean into ML ops. Examples, I just made the font bigger, that's really all I did, is I can provide pre-trained models, again, to interpret speech. If you use PowerPoint a lot, for free, built-in PowerPoint is a translator in real time. English to Thai, Thai to Japanese, all built in. Vision tools, again, all these are available. You can go to the APIs on the web, and again, you'll see a stack that, again, is our intent to understand that you want to mix and match all these things together to do your job, rather than have a highly proprietary process and set of tools. Okay. This leads us then to how to take this work and get it into production. I'm calling it ML ops, machine learning ops. You should not think that this is different than DevOps. What we're doing is recognizing that DevOps, the presentation earlier today was great. DevOps is as a practice, as a principle. We have to realize that in DevOps, there's some things you do for machine learning which add to it. Simple example. When you deploy a model into production, and that model starts making decisions or gets new data, the accuracy, the efficiency, the efficacy of that model changes. Therefore, this isn't binary code that either works or doesn't. Models drift. Therefore, we have to take a DevOps support process and add to it those skills so that production teams can recognize that the models we build drift. We're going to put telemetry on it. We need to be able to know when to come back, update the model. So all we're doing is taking DevOps as a process and a set of principles and adding machine learning characteristics to it. The pipeline, and there's a great session following this later where the KBTG team is talking about their DevOps process, and some examples are more specific, but generally the flow is fairly simple. From authoring to training, packaging, deploying, and then, as I mentioned earlier, the ability to monitor. There are huge investments on the part of my company, a part of Microsoft, to not only bring tools for data scientists to do their job, but including DevOps, data wrangling, because we recognize that to have impact at the scale, we need to provide a comprehensive set of tools for all of you to be very effective. Okay, we're going to start to wrap up. Talk about impact. I'm going to talk impact, and then I'm going to talk about culture. I felt it was appropriate, and you'll see other examples in the more detailed sessions this afternoon. I thought it was appropriate to talk about some of the things that are happening and some of the things that are being built. Earlier, I showed the same circle in the middle, and I talked about these 4 types of work that are being done. And then I just simply selected almost just as examples that we see lots of. Again, I have hundreds and hundreds of examples to pull from. And it starts with some really, whoa. Sorry. There we go. The meat and potatoes of data science today and for the last several years has been around predictive maintenance. Complex machines in hostile environments break, and it's very expensive to get them, fix them, and know they're going to break. Humans can be thought of in a predictive sense. Humans, sports players, kids break, get sick. Processes can break. Anything you can do to instrument a machine, a process, a person, and then look at patterns when there's been problems and start to predict saves you an incredible amount of time and money. It's much more effective if you're going to go out and do maintenance on a wind turbine in the North Sea to do it at the right time. It's very expensive to do. And while you're there, maybe you're going to do some other things on the turbine that's adjacent to you. That's why I consider it meat and potatoes, extremely well documented, lots of models, lots of business cases. This stuff works, and it works really well. In the financial space, the same kind of thing where you want to predict expensive bad habits like fraud is also what I would consider meat and potatoes. Maybe that's a North American term, and standard things, right? And we see fraud detection moving from literally people doing fraud detection in an omni-channel environment in a week to minutes. There's no reason you can't detect patterns of fraud that span the credit card, the ATM, phone calls into branch within seconds if you do it right. Huge, and obviously companies like Amazon have framed the general problem of being able to personalize. The demand for highly consistent and highly personal relationships with your customers is game-changing. And companies that become customer-centric reap huge rewards because you're basically connecting with people much differently. To do that, the ability, and I call it here Customer 360, which is this concept that rather than seeing a customer as just that person that came to the branch or the clinic or the call center, putting all that together and understanding their life with your organization and their relationships with products and others is pretty fundamental. Those two categories alone are probably 75% of my business. Here on the left are some really cool things. Productivity can skyrocket. Earlier we were talking about the data science process, and I said there's no reason you can't use tools to take all that data wrangling and sorting, do that over here. Take the production and support, put it over here. It's the same thing. That's how we increase the productivity of a data scientist. Here I'm talking about the productivity of field engineers, which allows them to understand what machines to service when, and we see this a lot in healthcare now. In the US at least, home healthcare is becoming bigger and bigger. And the ability to know which patients I should go see when as a function of traffic, what medications they're taking, the temperature, all these kinds of things drive a level of efficiency that can improve care and make nurse practitioners very productive. The exciting work is, I left it deliberately vague, is on new business models. As we move from a culture where people interpret the data and people make decisions on it to where the data suggests what might work, you find some amazing business models at the intersection of data and process that can be defined by the systems themselves. Let me give you two simple examples. There's a trend in investing now as shareholders, people like me, demand that if I'm going to invest in a company, I don't want to just understand its financial bottom line. I want to understand its environmental and its community bottom line. What's the sustainability profile of that company? Where do they do business? Do they understand, are they sensitive to environmental sustainability? So those dimensions that uniquely say that I, as a person, and my own personal interest in environmental care can be reflected in how I think my personality can all be driven and open up completely new investment models. Similarly, we see organizations that are so good at using their data, they can offer analytics as a service to their customers. Think about a large bank, perhaps offering analytic tools to small businesses. So the ability, if you're really good at data, to unlock new business models is profound. Does that make sense? It's a broad spectrum, and I just wanted to illustrate a couple of exciting examples and then close on an even neater one. This is the area that my team is doing quite a bit of work, which I just generically call Edge. So all those examples I just showed a minute ago implied a single model and a single problem Data coming in, I'm listening, interacting, and giving a result. Imagine that every one of those wind turbines has a model on it in a little container, little Docker container. A model tuned to, and the reason you do this, those turbines aren't all the same. They may be from the same manufacturer, but they may be different models built on different date with different maintenance requirements. They are different places in the wind field. The ones on the front of the field, heads into the wind, take more load than the ones in the back. In fact, they create a wake effect that you can predict. And so earlier, I've just been talking about modeling at the level of predictive maintenance of one turbine. But if I have a field of 1,000, I get to the point where I'm understanding these models are personalized to each turbine. They need to talk to each other. When the gust comes, there's no reason that the turbine in the front can't tell the ones in the back what's coming. They need to communicate like one, and they need to communicate back to a central model because there's more than one wind farm. My point is we're getting to where we have to manage models of models. Okay? So these tools around model management, versioning of training data sets, never has DevOps been more important, because literally you may have an environment where you have your model trained on 8 different data sets in 20 different wind farms across thousands of turbines, all talking. That's model management at scale. That's training set at scale. So there's some exciting work coming out. This is what's fueling a lot of the research in the industry and a lot of the projects that my specific team is working on. Make sense? Okay. Start to wrap up. Earlier, I provided perhaps some suggestions about skills that I look for if you were to come and say, I'm going to take my data science career forward, what are the kinds of things I should think about as I work in this environment? That was the selfish part that says I'm trying to ensure that we as IT communities are stepping up to our responsibilities to be fundamentally part of the business and do great work. This is my advice to you about when you think about where you work. What I've found is all those successes on the previous page have all come from companies that have 5 basic characteristics. The most important 2 are in the middle. Companies, I think of them as our customers. Companies that are customer-centered. Again, the opening comments this morning. If you think first about the experience you're creating for your customers, not the budget process, not which silo in the organization you work on. You think about the experience you're trying to create, you will always do the right thing if you put the customer first. That cultural way of thinking ensures that the work you do is as impactful as it possibly could be. The second thing that's fundamental is being data-driven. This is a vague word, I know that. But the point is that companies that take data seriously, they don't tolerate silos of data. They think about consistent semantic definitions. They understand their data, they use it as an asset. That's fundamental. Can you imagine now, if you're a data scientist, you know where to work somewhere, with those 2 environments, this puts data science, analytics, and IT, not as a cost center, but right in the middle of the business. Then there's some nice to haves that wrapped around it, which include working in a place that can actually have impactful outcomes. It doesn't matter if it's a small nonprofit that's working on ocean acidification. It doesn't matter if it's a huge bank or the World Bank or a humanitarian organization. You need to work in places that have the ability to have true outcomes that resonate with you as a human. Finally, innovation is fundamental. All of those ideas I described came from companies who have the ability to look forward, consider themselves innovative, plan for that innovation, and in doing so, they recognize that they'll fail. They know how to fail fast, they know how to take chances, they have expectations set. It just creates this fluid, fun, challenging environment. And the final one is this culture. If I'm going to talk about failing fast, you literally have to have a culture that recognizes that, rewards it, celebrates it, learns from it, and moves on, and obviously integrity. So my thought is, if I could offer you anything, is that we have so much possibility about what can be built. And if you can find a way to, more and more, because these technical jobs we have and the data we work with and our potential to change not just business but the world, these are important things for you to think about to make sure you're working in a place that you can have the greatest outcomes as possible. I'm going to wrap in 2 slides. that are a little bit more things to think about, because I'm supposed to talk about data science and Agile. We talked about the role, we talked about Agile to some extent in DevOps. But broadly, when you think about where this is headed, I have to talk about AI, artificial intelligence. I sometimes call it ambient intelligence, but the point is the same, is that increasingly, and throughout this presentation, I just simply offered that the systems we're building are there to augment, to nudge, to assist, to help. They're not replacing. Increasingly, we're going to be challenged in this next decade with ethics. If the system were to make a decision that affects whether somebody gets a loan, who gets seen first in the emergency room, we have profound ethical implications. Same with privacy. Within Microsoft, there's a book on this. You can dig into how we think about the future. We take this very seriously, and there's boards, ethic boards, and those kinds of things to review. So it's an important element to think about, is as we start to build systems that affect outcomes, we have to ask ourselves, what is our own personal and ethical responsibility as companies and humans to the systems we're building? And there's a really fascinating set of literature to read in this space. The other thing I'm always proud to point out is that if I can listen, this is really simple, and this honestly is my personal passion. Earlier I talked about listening to a wind farm. Thousands of turbines working on kind of the same problem together. There's a neat white paper from our chief environmental scientist, his name is Lucas Joppa. I apologize, I should have put the link on here, about how you listen to the earth. We're literally on this edge of compute, where with $5 sensors that can sit in a tide pool or in a forest, literally we're on the edge where we can use these tools to listen to the earth itself. And you'll see programs from Microsoft like AI for Earth, which are grant programs to nonprofits around the world to start to provide them Azure tools, techniques, data things, to start to pull this fabric together, which spans companies. Accessibility, designing for people who have different ways of accessing systems, is fundamental, and again, using AI to help humans themselves. One of the best projects my team has done in the last 2 years was a simple project around supply chain optimization for food, supporting the Syrian refugee crisis. My point is that if you think about using these reusable components and you think about what you're building, realize you also have, because of the open source culture we have now about sharing neat ideas, and if there's a way that all of you, when you're working on supply chain optimization in your companies, can think about maybe sharing those models back to a place where they can be used by a nonprofit company, a nonprofit organization in Africa. We're all part of this broad community, and that's really my message, is that the data science community has profound opportunity, and you have awesome jobs. Thank you very much for your time. Kap kun kruk.